Right, so here's a scatter graph, okay? So what you always get is a table of data and then you just draw the graph. Okay, so it's not too bad, right? So what you've got here, it's just showing you the spring when a force is applied. Okay, so think of a wee spring and you apply a force. You might do that in physics. So what you've got, bit of graph paper and force on the x-axis, length on the y-axis, and it's a matter for you to actually put in the just mark off the coordinates. So if we have a wee look at the first one. So the first one, a force of 1 gives you the length of 3. So you go down here, 1 and 3. Okay, so you mark that off. Next one, force of 2 gives you 3.8. So you go 2, go up 3.8. So by the looks of it, every small square is 0.2. Okay, you then have a wee look and it goes 3. Okay, is 5.4. So if I look at 3 and then I go up and then 5.4, which is roughly, should be there. We then look at 4 and it's 6. So if I look at 4, I'll go up and we should be able to mark off 6. Look at 5 and it's 6.8. So we look at 5 down there. If I go up, it's 6.8. And lastly, 6, and that is 8.2. So I'll see if I can squeeze that in there, and that's 8.2. Now, obviously, it's not a straight line, and what you don't do is start connecting all these up like dot to dot, okay? So you get marks for actually plotting it out correctly, and you also obviously get marks for drawing the line of best fit. So it's when you look at it, it's really the direction it's pointing. Okay, so if you think about it, if you were to draw another point, it would be roughly around about this way. So you get a ruler and just think about, you can grab this pencil, just think about what way is this generally pointing towards. Okay, now you might get the wee rule, you try and have the same amount of dots underneath it as below it, but obviously you don't want to get into a stage you're doing that, okay, saying, well, that's 3 below and 3 above. It's really what direction is it actually going towards. Another thing you don't want to do is always think it starts at 0. That's not the case, okay? So you're wanting to think about starting and having it going in the same direction. You might have one that's slightly different than the person next to you, okay? So use this pink ruler and I'll draw one here, okay? So it's, and the ruler's not quite long enough. So I'm just going to draw it roughly about there. And that just goes on. Okay, so that's roughly the direction it's following. Now, having the line of best fit allows you to then estimate other values that you haven't plotted in your graph. So use your graph to estimate the length of the spring when a force of 3.5. Okay, so all you do here, and I'll try and grab another colour, right? All you do here is you go, well, 3.5, and you follow that all the way up to the line, and then just mark it off. Then, and I'll use maybe the green pen, you then have a wee, with this, and then you just, when you hit the line, go right angles and head towards the other axis. And this can be your estimate, this one here. Okay, so that looks to me, so we've drawn that line of best fit, and so that looks to me when it's 3.5. Okay, so you draw from 3.5, and draw that up. You, as soon as you hit it, you take a right angle, and then you go to the other axis. If we're saying that's every 2, that's essentially about 5.6. And is this a reasonable estimate? Okay, and then we just need to say this estimate is good. So there's three parts to this. You get given coordinates, you plot it out, you then try and draw a line of best fit. You'll then be asked to use this line of best fit to then do an estimate, because that's the whole reason of it. So they'll give you one value, and then from that you then find the other. So for instance, say it was find it with a length of 5, you'd look at 5, you would then go along and then come down, okay, and then you'll take the reading from here. What I'll do though is I can show you, just to prove line of best fits aren't always the same. This is the actual official answer, so it's quite similar, right? But using their line of best fit, we got the approximate of 5.4, so 5.4, 5.6. It's still a not too bad estimate. So that's how you do a scatter graph.